Hi, welcome back to the Maxi class. Now, today we are going to solve more questions on the circle theorems we began. In the first video, I explained certain principles to you and explained to you that the only way you can understand the circle theorem is to go through the principles, get to understand them. Then once we begin solving the questions, we can apply the principles. Very easy. So if you don't have the first video, if you have not watched the first video, you need to go and watch the first video, get the principles, then come here to the second video and come and follow the applications and the solvings here. Very important. The principles are what we are going to use in solving the question. In a question, we might get to all the principles in it, no problem. The most important thing is that what am I seeing? What do I have? You get the point I'm making here. Example, if I read a question, the question tells me that in the circle, O is the center. Automatically, I shift my attention to all things connected to the center. That's how we solve it. So it makes the work easier. Good. So if you have your notes, if you download the notes on page 5, I'm doing the first question on page 5 so that we see how we can now apply this. Let's go straight into it. First question on page 5. First question on page 5. First question on page 5. I have this. I have that. First question on page 5. I have AB. I have C. I have angle P here. I have O here. I have 82 here. The question is to find the angle at what? At P. Find the angle at P. Now, if you look at this thing, O is the center of the diagram. Since O is the center, then the first principle we learned will not work here. Because that one dealt with the chord. But here we're looking at what? The center. And one thing they mostly will do is to omit the chord. Take note of that. In most of the questions, they will omit the chord, expecting you to know that these triangles are sharing the chord. So if you don't see the chord, you can represent this with some broken lines as your chord. Now, what were some of the things we said about the center? In the previous video, we said that the angle, once we have an angle at the center and another one at the circumference, then 2 times the angle at the circumference equals the one at the center. Remember that we said 2 times the angle at the circumference equals here. How do I know I'm supposed to apply this? O is the center. Then I'm going to focus on the center things that we have discussed. So in the center things, what do we say? We said that, okay, one of the triangle must be at the center and the other must be at the circumference. Any part of the circumference is fine. And there was a secret we looked at, that the angle, the arc, or the shape of the arc must be the same. Good. So in this case, we are going to say that then 2 times the one at the circumference equals the one at the center. So 2 times of angle P equals 82 degrees. This is what I'm going to say. 2 times the angle at the circumference equals the angle at the center. So here, if I want P will be equal to 82 over 2. That gives me, this will go into itself, go into this 41. So P equals 41 degrees. Very simple calculation. But as we go on, you know how games are played. Stage 1 is very simple. As we move on, it's still simple, but the principles will now be applied. Here they give us only one principle. We are fine. But in the next question, they might put 2 or 3 together. No problem. Once we have a center, anytime you read the question in here, O is the center. Oh, just come and do your center things. And any line that goes to the center is the diameter. So if you hear the center, then any line that goes through the diameter, then the triangle subtended on such diameter is what? It's 90 degrees. So this is the first one. Let's go to the C one, the C question. Still on page 5. Still on page 5, the C question. C question. So most of the time, the angle here, the chord will meet it, no problem. So the angle here is 40 degrees. And once again, the angle here is P degrees. So you find the angle P's here. Now find the angle P. O is the center. You hear that? O is the what? The center. If O is the center of this, then what do? We have to apply the center thing. So one of the triangles must be, I can complete this, one of the triangles must be at the what? At the center, and the other at the what? The circumference. So the same thing I did here, the same thing I'm going to just apply the same concept. See, the diagrams are different, but the concept behind the diagram is the same. How am I saying that? one triangle at the center, they share the same chord, one triangle, one a circumference. Wherever it's on, I don't care. But it's at the circumference. Good. So that means once again, 2 times the guy at the circumference equals the guy at the what? The center. So this gives me 2p, or p equals 40 over 20, or 40 over 2, and that gives me 20. So I'll get what? I'll get p to be 20 degrees. P equals 20 degrees. Good. So that's how we also solve this. That's how we also solve this. That's how we also solve this. Our next question. Let's take the question on question number 8. Still on page 5. Let's go with question number 8. Question number 8. I hope you have the note. If you don't have the note, you don't get the question. But all the questions are in the note. So make sure you've downloaded the note from the website www.mactclass.com. Then you get the note, you follow. We have this. This O is our center. The angle here is 60 degrees. Okay, so let's go. Question 8. In the figure below, let me label the parts. This A, that is B, that is what? That is C. In the figure below, angle AEB, so here should be, so it should be angle ACB is 60 degrees. ACB is 60 degrees. So let's go with that. Then, what is the measure of the reflex angle? What is the measure of the reflex angle? Reflex angle is an angle that is greater than 180 but less than what? 360. So this is the angle we're looking for. And here, if you don't know angles part 1, then you have to go and watch the video on that, where we explained, I told you earlier on, that this part 2 of angles. So if you don't know part 1, because we're going to apply some of the part 1 principles here to work this. No problem. What is the principle here? We have a center, because the question said that in the figure below, this is that, and that we see O is our what? O is our center. Okay, since O is our center, then we have a triangle at the center, then a triangle at the circumference. No problem. I want to put an angle, I want to introduce my own angle. Anytime you introduce your own angle with a letter, you have to draw the diagram again on your answer sheet. This is very, very important. Why? Because you will submit the answer sheet to the guy. The question part you take home. So when you put your own angles here on the question paper and you take it home, how will the person know what angle you are referring to when you have worked with it on the paper? So make sure that anytime you introduce your own, and I like to introduce my own angles, because using AB, angle ABC and this calculation, at times becomes so complicated. So I like to introduce my own angles by drawing the diagram again, then working with it. So I'll introduce a new angle here. Let me call the angle here X. I know that 2 times the guy at the circumference should be equal to the guy at the center. So 2 times, I know this. How do I know? They share the same chord, one center, one circumference, no problem. So that means my X equals what? Equals 120 degrees. But the question didn't tell me to find X. X is not a reflex angle. I have to go and find the reflex angle here. What is that reflex angle? We know that when angles meet at a point and their arcs complete a circle, then we add it to what? To 360. Good. So once again, that my angle, which I was supposed to go and find as angle AOB, the reflex angle, I would like to introduce a new variable, which is what? Y. So I'll tell them Y plus X equals what? 360. Angles at a point. It's along with the person marking this understand. So I have Y equals Y plus 120 equals what? Equals 360. And this will give me Y equals 360 minus 120. That gives me 0. That gives me 4. That gives me 2. So therefore, the reflex angle is what? The reflex angle AOB. Angle AOB equals 240 what? Degrees. 240 degrees. This is how I'm going to solve this. Very simple. I apply the principles to do that. Like I've said, if you have a problem with angles 1, then you have to go and look for that. There's a video on that. Go and look for it and watch that video. And watch the video. Let's go to the next question quickly. Okay. So now we scroll down to page 6. We are looking at question 10A. I will do question 10B before the 10 what? The 10A. I want to do question 10B before the question 10A. I'll be choosing random question. We can't solve all the question, but in case you want us to solve any question, give us the question number in the comment section. We'll come back here and solve it for you. That's for you alone. Okay, so we're on that question. I have AB. I have AB. There's a triangle on this. Then there's another triangle sitting on this one with an angle here. Always the arc tells you the measure of the angle. So this small angle is the angle X. If you look at this measure, is 70. That's one thing that you guys also get confused. Don't get confused here. Anytime looking at the angle, check the what? The distance of the arc. The fact that they've written 70 here doesn't mean that it is this small angle at 70. No. It is the length of the arc that gives you the angle. We don't want to write it through the line. That's why we put it here. So take note. If you look at the length of the wall, of the arc, or the degree to which the arc is drawn, is what gives you the angle. So here it's 45 degrees. Good. So I want to read the information in question 10. So I use that to answer AB. Good. Find the marked angles in each of the following diagrams. O is the center of the circles. So if O is the center of the circle, but here in this case, we don't have O. So that means I will not think of anything here. There's no center here for me. Look at the diagram. There's no center. So I will not think of anything. I'll go and think of the chord properties and see if I can apply what? The chord property. Should the question show me the center, I would have known what to do with this. But the question didn't show the center for this diagram. So I'll not go anything with what? With center. No problem. Now, in the first principle, we said that if we have two triangles sharing the same chord, so this is their chord, this one is subtended here, and this one is subtended here. Once they are in the same direction, then the angle here is equal to what? The angle there. Am I making some sense here? I'm making some sense here. Good. So in this case, we are going to have the angle here. Here will also be what? Will be 45 degrees. Why is that? So I'm doing this when I have drawn. Once again, I'm taking time to say this. I will do this here when I have drawn the diagram again on my question paper, so that my answer paper, so that the person marking will now reference to my diagram to solve or to also follow my calculations. So I know this is equal to that. Therefore, if I take this triangle, the label these as C, D. So these were the triangles. Now, I'm going through this again. I said this one is the chord, that's another chord. They all share the chord. So this one is 45. That is also 45 from the first principle length. Once they are on the same chord, they face the same direction, they turn this, and the angles are the same. So when I consider triangle ACB, what can I say from there? I can say that angle 45 plus angle 70 plus angle X should be equal to what? 180 degrees. I can say this. Then I add 70 to 45. So that gives me 70 plus 45, and that gives me 5. That gives me some 11, right? It gives me 11. So I have 115 plus X equals what? Equals 180. So X should be equal to 180 minus 115. I borrow 1, I get 10 here. I'm left with 7 here. 5 from that gives me 5. 1 from that gives me what? Gives me 6. Therefore, my X equals what? Equals 65 degrees. 65 degrees. Very important. I hope you saw how we solved the question. There was no center, but applying the first principle, this is a chord. You sat here, I'm also sitting on the same chord, so we share the same angles. So this is that. And I consider the triangle ACB. Consider that triangle, I can solve for what? For X. Then I have my X. Good. So that's how we solve for X. That's how we solve for that one. X. Okay. So more questions. Let's do more questions. Let's solve more questions on this. More question. We're going to question. Let's choose question 12. Let's do question 12. Let's go for question 12. Okay. Let's go for question 12. We are finding the angle ABB. The angle ABD. The angle ABD. So let's draw this. Let's draw this and go. Okay. So this is what? This is AB, the line AB. This is my chord B. This is the other one, which is a C. So I have this. This is O, and that is what? That is 70 degree. Question says that A and B are diameters of the circle with center O. They are diameters of the circle with center what? O. Now, one thing you should know, there are so many ways of solving this question. There are so many ways you can do it. It depends on what you are seeing. Once I told you, these guys too can be completed so that you can get your diagram complete. You can complete them so that the diagram looks complete for you. Now remember that the guy is telling us that the A and the A, B, and C, they are diameters. If he had not said the moment O is the center, then any line that goes through the center is the what? Is the diameter. So what do we know? Since we have this, we can boldly say that, in fact, in the previous video, we also said that once we are in the center, then the angle here must be equal to the angle because we form an isosceles triangle. Don't forget the tricks. Once there's a center, the triangle at the center is an isosceles triangle. So the angle here is the same as the angle here, right? And the question says we should find angle BABD. Angle ABD. So we want the small angle here, ABD. Normally, if you are given an angle ABD, the letter in the middle, that is where we can find what? The angle. I hope you get the point I'm making here. The letter in the middle, that's where you can find angle. So if question tells me to go and find angle ABD, that means I need the angle here. No problem. That's no problem at all. I know that from triangle, so I can say that from triangle, before I come there, let me calculate this angle here. Let me calculate this angle. Now, do you know that if I know this angle here, this angle, before I start solving, if I know this angle here, this angle plus that angle should give me 180 because there are angles in the triangle. But I know I'm applying the principle of isosceles triangle that since these guys are the center, then this guy is the radius, making this and this isosceles. I hope you get the point I'm making here. Good. So that means I'm going to find this one. For me to introduce my own angle, I'm going to draw the diagram on my answer sheet or answer booklet. So this will give, let me put X here. I like to go with X. So once again, I'll say what? 70 plus X equals 180. That'll give me X equals 180 minus what? Minus 70. And that gives me S equals 110 degree. Don't forget to add a degree for your last answers. If you forget them here, make sure that your last answers will have what? The degree. That's what you have done is wrong. Because it's not an angle. 110 can be anything. Okay, so now that I have X, with what I have just said, that this is an isosceles triangle, then I'll say that from triangle DOB, I'm putting an angle Y here and an angle Y there because the angles are the same. So in that case, I'll get X plus Y equals what? Equals 180. If I have this, then I'm going to see what is X. But I know X is what? 110. So 110 plus 2Y should be equal to what? Should be equal to 180. So then I have 2Y equals 180 minus what? 110. So 2Y equals 70. And I divide that into 2. So I get Y equals 70 over 2. Y gives me 35 what? Degree. And therefore, angle, the question said they wanted angle ABD. This angle, therefore, angle ABD equals what? 35 degrees. I found the angle for them. 35 degrees. Very, very simple way. But you see, when you don't keep the principles, you can't do it. If you don't know that once the triangle is at the center, it gives an isosceles triangle, then you will find a little bit more difficult doing this. But once you know them, I said this is one of the easiest things. But most people find it challenging because they don't listen to the word, the principle, because they don't apply the principles here. Okay, let's also take question 14 and solve the same question 14. Find the angles marked with the letters in the following. So we are finding the angle X and Y. I think question 14 follows the same thing we have there. Follows the same thing. So let's go to the next page, page 7. Let's go to page 7 and solve. Let's go to page 7 and solve for which question number should we go for? Which question number should we go for? Let's go for question number 16. Okay, so question number 16. Let's go for that one. Question number 16. Then I have this, I have that, I have this. Okay, angle here, they put an angle there. This is 40 degrees. That's P, B, A, C, then D. Then the angle here, it's 30 degrees. They put 30 degree here. Okay, no problem. No problem. Now let's read the question. Question 16 says what? Two chords A and B. Chords A, B. Two chords A, B. And which other chord we have here? Which is our which is C, D. So these and these are chords. While they are chords, when a triangle sits on that chord, remember that the angle of the triangle must be what? Must be equal. That means this, if there's a chord here, then the triangle sitting on this triangle and that triangle must have the same what? The same angle, the same thing. The chord here should mean that the angle here is the same as the angle here. We are applying the chord properties. So when your question is given to you, don't look at the complication of the question, but begin to apply the principles. So the question told us that A, B, and C, D of the circle are chords and they intersect outside at what? At P. So they met here at what? At P. No problem. No problem. When the circle is what? Is when circle or outside the circle when produced. Now the angle B, C, D is 30. We have that one. Then angle A, P, D is what? It's 140. Okay. We should find them the angle A, D, P. They want this angle. Angle A, D, P. They want the angle here. But the question is, how do we get that angle? How do we get that angle? That's the question. Now, do you know that if I'm able to get this angle, if I'm able to fight to get this angle here, then if I get this angle, the angles on the straight line, I can get this. Like when I'm able to get the angle here, then the angle here plus the angle here will give me that angles on the straight line. I'll get this from angles part 1 or the part 1 of angles. Okay, so what do I have here? Now, we can apply so many things. Let's see what is working. We have 30 here. So the angle here can also be 30. That's what I proved here. That since you are sitting on this, if here is 30, the angle here will also be 30. Okay. But look at what is happening here. Look at what is happening. This guy, that guy, and this guy is what? It's a triangle. Look at what is going to happen. This is a triangle. C, P, B is a triangle. I hope you can see that. Now, if that's a triangle, then the sum of angles in the triangle must give me what? Must give me 180. If I'm able to know this angle, do you know that if I know this angle, angles in the straight line will also give me this angle? And when I know this angle and that angle will be equal. And once they are equal, I can tell this. I just want you to see the way I'm applying the principle. So if you are weak in the part 1, this is part 2 of angles. I'm applying something from part 1 which says that triangle A, B, P, this triangle A, C, B, P is a triangle. Okay, then this one plus this one plus this one must give me 180. So I will introduce my own variable. Variable. So I want to call this whole angle. I told this whole angle, or the arc tells us the measure of the angle. I want to call this whole angle X. So I can say that I will say this, that the person should go and look at triangle CBP. From there, he will see when he goes to check that 30 plus the X I have placed there after I have drawn this thing on my answer booklet, then plus 40 should be equal to what? 180 degree. I have this. Are you okay with this? Good. So then I can find X. So when I find X, I'll get 70 plus X should be equal to what? 180. So X equals 180 minus 70. So my X equals what? 110 degrees. I have X. But my aim is to get this angle here. So once again, I place a variable Y here and say that Y plus X equals what? Equals 180. Angles in a straight line. So once again, I can say Y plus X equals 180, and that is angles in a straight line. What is x? X is 110. So I have y plus 110 degree equals what? 180 degree. So y should be equal to 180 minus 110, and that gives me y equals what? 70 degree. I have y to be 70 degree. The person is following. I'm here. I'm saying that if this is my chord, which is chord CA, then the triangle sitting on the chord, which is this triangle, and that triangle must subtend the same angle. So you get the point I'm making here. Yeah, I could have used another way of doing it, but because they've not mentioned anything about that, I'm not going that way. I'll go this way. And you might have seen a different way of doing it. There are so many ways by which you can do this. Good. So the angle here is equal to what? The angle here. Why am I saying that? I'm applying the chord. That these two triangles are on the same chord, the same direction, touching the circumference. Then I can say that. So I can also say this is what? This is y. The person marking must understand, because I've already drawn this. So I tell the person once again that y plus what angle is that? The angle is what? Angle ADP. Angle A. The angle ADP equals what? Equals 180 degree. That's also an angle in a straight line. I hope you get the point I'm making. This y plus this angle here equals what? 180. So I'll get y equals y, which is what? 70 plus angle ADP equals what? 180 degree. I'll get the angle ADP equals 180 minus what? Minus 70 degree. And the angle ADP equals 110 what? 110 degrees. Very, very what? Important. Very, very important. Hope you get what I'm saying here. Yeah, so this is very, very important. Now, we have solved this angle for them. We have solved this angle for them. Good. So I hope you get a point or the way we're solving the question. Yeah, very, very important that you understand. I'm still applying what? The principles to solve this. Still applying the principles to solve this. Yeah. Let's go straight. I want a question with a tangent so that we can know how to do or solve the tangent questions as well. I want a question with a tangent. A question with a tangent. Okay, but before that, even on page 11, I want to look at the question 22. Page 11, question 22. There are so many interesting questions, but we can't go through. We are solving some of them so that when you're also going through and you have any question, as if you have any question, put the question number, the page number, the question on the comment section, and we'll come back and solve them for you. Good. So basically, let me solve that. So on page 11, question 22, let's try solve that one. I hope you have understood this. Yeah, so this is all the circle theorem that you guys are scared of. Just know the principles involved and apply the principles. Once you apply the principles, forget the diagram that is drawn. What do I have? Do I have a chord? Do I have a center? What are the center things I know? With a little help from angles part 1, you should be able to solve any angle or question. Any angle question, you should be able to solve it. Okay, so let's go with that question. Page 11, question 22. Page 11, question 22. Page 11, question 22. We have this. I have this. I have that. And there's a center here. Center there. And there's this triangle that goes this way. No problem. I said, don't get scared of the diagram, but make sure you just apply the principles. No matter what is given there, that shouldn't be your problem. No problem. Just read the question, understand, then let's solve. AB is a chord of a circle with center O. AB is a chord of a circle with center O. When we hear center, what are we looking at? We're looking at the fact that we can have isosceles triangle. We can also have the diameter, of which here we don't have this, so we don't even think of that. And we can also have the center where the angle at the wall, at the center and the circumference are connected, such that 2 times the angle and circumference equals this. I hope you get a point. So we apply the second principle that we talked of in the previous video here. Okay, no problem. And they say this is, then we know this is 90 degree, obviously. Good. So reading, I see AOB is 90. What are the measures of angle? What are the measures of angle? What? Angle ACD. Angle ACD. What are the measures of angle ACD? angle ACD. How is that? Measures of angle ACD and angle ABD. Angle ABD. So they want this angle here, ABD. They want the angle here, but the other one, which is angle ACD. Angle ACD. AC. It should be angle ACB. Should be angle ACB, not ACD. So angle ACB, not ACD, but there's no line there. Let's retrace our own line. But so let's go with angle ACB. Okay, no problem. We had and then we find the angle here. Okay, we find the angle here as well. Okay, then angle ADB. ADB. Oh, so the angle here they want, not even there. ADB, the angle here. Okay, oh, then now it becomes very simple. Now it becomes very simple. Let's go. Okay, so now we have our center. We have this one here. What do we know? We know that if I place my own variable here, introduce my own variable, then 2 times the guy at the one, the circumference is equal to the guy at the center. That's what we said. That since this triangle share the common chord, and they have what? They have one at the center and the other at the circumference. And the secret is that the arcs are what? Are all the same direction. Or they look at the same shape, then which we call the valley, then we can say that 2 times of this equals that. Therefore, we can say 2 times of the angle x equals the angle 90. So x should be equal to what? Should be equal to 45, or let me say 90 over 2. So x equals 45 what? Degrees. Found angle x. Found angle x. Good. Then the next thing here is to have what? Is to have this. We need this angle here, this angle, no problem. But remember that I showed you, I taught you in the principle that this angle will move with this angle. If we know the angle here, that means 2 times of this should be equal to that. If we know the angle here, we can tell the angle because of the what? The mountain. Why? Because once again, triangle AOB and triangle ADB are sitting on the same chord. One is touching the circumference. Which one? Triangle ADB is touching the circumference, and the triangle AOB is touching the center. So it works here. In the other video we explained. So it works here. That means this. Then the secret goes that the way your arc is drawn, this same thing goes there. Therefore, this guy and that guy are what? Are related. I want to introduce my own variable here. Why? Why would I do that? Because I've drawn the diagram again. So now say y plus 90 equals 360. I want to know that y equals 360. So I'll get y equals 360 minus what? 90 degrees. I borrow these, I'll get this will give me 0, this will give me 16. So when we subtract 69 from 16, 9 from 16 will have what? We'll have 7. So 9 from 16 gives me 7. Then I'm left with 2 here. So I get 270. Of course, 270. I have 270 what? Degrees. So now we know the reflex angle here as well is 270. So since the reflex angle is 270, we once again know that 2 times the one at the wall at the circumference equals the one at the center. So we'll say that 2 times of angle ADB equals what? Equals 270 degrees. We know this. 2 times the angle at the circumference equals the one at the center. We are looking at this and that. Good. So this will give me angle ADB equals 270 over 2. So this will give me angle ADB should be equal to 135 degrees. 130 what? 135 degrees. 135 degrees. Good. So angle this equals what? Equals 135 degrees. So I found that angle for them. And angle X was the first angle we are supposed to find, which is angle ACB. Angle ACB, yeah. And angle ACB is 45 what? Degree. People, these are the principles that we are applying. I'm not doing something new. I'm not saying something new. All the things I've already said is what I'm just hitting on them to solve what? To solve the question. I hope you are getting what I'm saying here. So once you know the principles, no matter the question, you should be able to solve the question. If there's any question you're finding challenging you, just give me the question number in the comment section, the page number, and I'm going to solve it for you. Okay, so I've gotten a question on the tangent that I need to solve here. Question on the tangent. When you go to page 12, the question H, I wanted a question on tangent. Question H. Let's try question H and see, because for tangent, I give you three things. The tangent with the what? With the diameter, the tangent with the what? With the radius, and the tangent with the triangle. Let's see how we are going to apply that one in this. Okay, so I have this, and that is my tangent. Let it touch properly. Good. So now I have a tangent. Then I have a center. The radius going through the center, and once I have a center, a line goes through the center, gives me the diameter. Any angle the diameter holds at any part of the circumference, I know it's 90 degrees. These are basic things that I need to know here. I know it's 90 what? Degrees. So this gives me A, and that gives me what? That gives me 50 degrees. So the angle here is 50 degrees. Angle here is 50 degrees. Very important. And I'm to find all A, B, and what? And C. I'm to find A, B, and C. That's no problem. What do I know about the diagram? I have a tangent, and I know that once I have this, the angle this automatically B equals 90 degrees. I don't think much. For B equals what? 90 degrees. Very, very well. Simple. Why? Because the diameter is subtending an angle and the circumference is 90 and nothing else. Okay, good. Now, how do I get the C or the A? How do I get C or A? The question is that when you go back to the previous video and look at the tangent critical, I told you that when we have this, the angle between the tangent and the triangle is always equal to the angle that is far. In fact, since the arc is touching this line, this 50 does not belong to this, does not belong to that, but belongs to that one there. Therefore, automatically too, we can say that angle C equals what? 50. So something you think is difficult, some positive and right. No. I'm just applying the principle. So since my arc is touching this line, the angle does not belong to it, does not belong to B. Because when you give it to A, B will start complaining that why not me? Because you're on the same line. When you give it to B, A also starts complaining. To avoid that complaint, give it to who? C. And that is the principle here. Good. Now we have this. How do I get the angle? I found AB. So how do I get the angle A? I found angle B and C. So how do I get angle A? I use the triangle property, which says that A plus B plus what? Plus C should be equal to 180. So I have A plus, what is B? B is 90 degrees plus this equals what? Equals 180. I'll get A equals, this will give me A plus 140 degrees equals what? Equals 180 degrees. So I'll get A equals 180 degrees minus 140 degrees. A equals what? Equals 40 degrees. Very, very simple. Very simple. So you see how simple the question is. Very, very well. Simple question. Very, very simple question. People will end this lesson on this. If you have more requests, they are going to do more videos to solve more. But there are a lot of questions there. Try them. If you don't get them, let me know in the comment section. I'm going to solve most of your questions for you. There are a lot of questions here. I don't want to waste much time on this, so just take your time, watch this one, and I'll bring you another video on the workings of what? Of circle theorem, so that before you sit for your Waasce, you can be grounded in the what? In the circle theorem. Thank you very much for joining this class, and I'm so glad you joined this. But remember that once you have this, you share to your friends for them to also benefit from this. Thank you very much.